Hi, I'm Kevin Bull. I'm with Veritech of Isola Company. Today we're going to talk about humidity monitoring in critical and regulated environments. This is not going to be a formal talk on thermodynamics, but an overview on humidity monitoring and the problems and difficulties associated with it. There'll be just enough science to give a basic understanding of the fundamentals. What we'll cover: why monitor temperature and relative humidity. We'll look at some definitions of humidity and humidity-related terms. We'll cover the actual measurement of relative humidity, as well as monitoring systems. And finally, we'll look at calibration and what's involved in a good humidity calibration. Why monitor temperature and relative humidity? Well, everything is a thermometer. All matter responds in some way to temperature. And almost everything is a hygrometer, and by that I mean it responds in some way to relative humidity. Many processes and materials react to temperature and humidity at some level, so it's important to get a good measurement of the environment in order to understand how these materials or processes may be reacting. Materials generally respond to relative humidity, not absolute humidity. We'll talk about the differences a little later. Humidity can get into and through most materials and barriers. Water molecules are very small, they're very polar and reactive. Water reacts with so many molecules that it's actually called the universal solvent. And that's why we engage in stability testing, to understand how water molecules will react with a given product or material, and also how water is able to get through a barrier of some kind. Material flow properties, such as powders, can be greatly affected by relative humidity, and in those applications, it's very important to monitor it to understand what may be happening. Static electricity can be generated when relative humidity is quite low, and this can interfere with different product manufacturing, medical devices, electronic systems, or again, powder or flow of various kinds. I think we all know that when humidity is low, static electricity goes up. And high levels of humidity can promote corrosion or even the growth of mold. So again, it's something that we need to be aware of. Water vapor permeability. By that I mean the ability for water to get through or materials to block the transfer of water vapor. Again, water molecules are so small and reactive that they get through many different barrier types. Plastics can be permeated by water. In fact, even some metals, even stainless steel, can be permeated by water molecules. Let's talk about measurement and where. Walls and corners of a chamber or a room are seldom representative of the entire room, and usually not the best place to get an accurate measurement from. Rooms can have enormous temperature and humidity gradients, and those can change throughout the seasons. Summer and winter conditions can be quite different. And large gradients can occur even within a chamber, particularly if the chamber is running at a temperature different from ambient. If a chamber is well below ambient or well above ambient, we can expect significant gradients, particularly along the walls or in the corners. And we also must be careful not to measure the airflow into a room or into a chamber. Those can be quite different than the conditions within the room or chamber itself. And again, if it was winter, for example, and quite cold, the air that's coming from the heating system will be quite warm. And if we're just measuring that, we may not get a good representation of the conditions within the room. And it's the same situation with a chamber.